Yay! Okay, so now that we've graphed the greatest integer functions and seen the different effects that certain transformations can have on this particular graph that looks like a step graph, because it is a step graph, we need to add this to our Cartesian catalogs. Okay, so as I mentioned with absolute value, it always has, every function that we're graphing has a parent function. That means that it is the function in its most purest, simplistic form. There aren't any transformations. And HK is 0 and A is 1. So here we go. Okay, for this particular one, we know that it starts, I'm going to make it a little bit larger. It starts at 0, extends out 1 unit, open circle, and it goes up. We saw this on the Skill 6 Part 1 notes. If you need to refer back to that for the coordinates and why it is such, please do so. And it is a little bit tedious to go 10 units down and up, so I'm not going to go the entire length. You guys get the idea. I know. You're probably thinking, Patterson, you pretty much did. Yeah, pretty much did. Okay, so that's what it looks like when H and K are 0. There's no horizontal or vertical shifts. And A and B are 1. Okay, no horizontal or vertical stretches and compressions. Our HK is, we'll say 0, 0. For the x-intercept and the y-intercept, I'm actually going to go against what I have been preaching to you. For the x-intercepts, and I don't know why we have double there. It actually, and here, let's do it in black. I know it doesn't matter, but that way it matches. Okay. There are an infinite amount of x-intercepts between 0 and 1. So we're just going to represent it by an interval that our x-intercepts exist between 0 inclusive and 1 non-inclusive. Okay, now the y-intercept, there is only one. This is a function. Okay, so we're going to say 0, 0. The domain is certainly all real numbers. There isn't any value that we could substitute in for our x input and not get a corresponding y value. So we say that it's from negative infinity to infinity. The range. Now the range is steps, right? And so there's these big gaps in between. What the heck? Where, like, there's nothing there. How do we write it? Well, you can write all integers because that's where our steps exist. Or you can write the symbol for integers, which is that fancy z. The range is such because it is a step function. The space in between the steps does not exist. Therefore, we just say all integers. Now, is this increasing or decreasing or both? The absolute value function had two different pieces, so we had both. But for this, we're going to say that it's increasing only because my steps are climbing from left to right. Remember, this is discussed with the domain elements, so we say it increases from negative infinity to positive infinity. It is not going to decrease. Now, is this function 1 to 1? In order for us to be 1 to 1, every x corresponds to 1 and only one y value, and every y value corresponds to 1 and only one x value. So, does this function pass the vertical and the horizontal line test? Because it must pass both. Well, no, because each step is its own horizontal line. So therefore, this is not 1 to 1. There isn't a rate of change from one point to the next because they're tiny snippets of constant functions. So we say NA, it doesn't apply. There isn't an axis of symmetry because this is not a symmetrical graph like our absolute value function was. There isn't a minimum or a maximum value. And there aren't any asymptotes because, again, we don't know what they are yet. So there is our step function in parent function form. Sweet. Okay, now referring back to what we saw in the notes for part 1. A, B, H, and K all have different effects on our step function. The first thing we need to do is factor out the B value. Always. If you need to write that down as a reminder, please do, because that is one of the most common mistakes that students will make, is they don't factor out the B value. Okay, so if we factor out a -1/2, well, travel with me, if you will, to my thought bubble. Here. See? It's my thought bubble. Okay, we're taking 2 and dividing it by a -1/2 because that's what factoring is. So then that means we have 2 times -2/1 because with fractions, when we divide, we keep the first and then change the operation to multiplication and then multiply by the reciprocal of the second. So that means this is x minus 4. If you're not sure if what you did is correct, then I would recommend distributing the -1/2 back into the parenthesis. Multiply it back in. If you did it correctly, you will get the exact same answer as you started with. Okay, here we go. Let's identify. Well, A is 3. And if you look back at your notes, yes, this is a vertical stretch. Sorry, little Patterson drawing. Which means that what is happening to our step functions? Aha! This is the distance between each step. Distance between each step. Okay, our B value is a -1/2, which means a few things. Whew. It means we have a horizontal, because B affects the horizontal reflection. And remember in the notes, we saw that if B was 2, it shrunk our step length. And if B was 1/2, it lengthened. So this means we're going to have a horizontal stretch. Anything inside of the grouping symbols, such as B and H, will be a horizontal transformation because it's inside with the X. And don't worry, we're going to talk more about this throughout the whole semester. So don't worry if it's a little bit of a strange concept. So this means we are going to, since it's 1/2, lengthen the step. And we're going to reflect. Now, H is 4. Remember, we always take the opposite sign for the H. So we go 4 units right. And then K is 2, which means we go 2 units up. Okay, normally we start at 0, 0, but since we have an H and a K, and I'm going to make this a little bit wider, we are going to shift over 1, 2, 3, 4, and up 1, 2 units. Okay, our step length, that's the next thing you want to address. So step 1, where do I start? And if you need to, write it down. Step 1, starting point. Step 2 is the step length and the direction. So we know that I'm going to extend out my length 2 units, but there's a horizontal reflection. So that means we're going to go to the left 2 units to my open circle. Remember from the part you guys watched in class, that has the effect to go left if there's a negative inside of the brackets. Okay. Step 3 would be, do we go up to the next step or down? And then step 4 is how far? So since we do have a horizontal reflection, that means that to the next step, we go down. And since there's an A value of 3, I'm going to go down 1, 2, 3 units to my next open circle and over 2. How do I know it's an open circle? Because you cannot have closed circles at the same X value location. Otherwise, it's not a function. So then I'm going to go down 1, 2, 3, open circle, extend out 2, and I'm going to work 1, 2, 3 in the opposite direction as well. A little bit of reverse to get the full gist of what this function looks like. Okay, again, vertical stretch because the A was 3. That means that I went 3 units down. Why did I go down to the next step? Because there was a horizontal reflection. Okay, both reflections, both vertical and horizontal. So if there's a negative on the outside of the bracket or inside the bracket, causes us to go down to the next step. The horizontal reflection causes us to have a closed circle at our starting point and then extend left to the open circle. That's the difference. All right, so HK, we wrote it down, we graphed it. We know that it is 4, 2. Looking at our function, it does not have a step on the x-axis, so we're going to say that it does not exist. There is a y-intercept, and it's not at the open circle, it's at the closed. So counting up, we get 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8. Of course, we could always substitute in 0 into the equation and solve for the y-intercepts. You are absolutely always 100% welcome to do that. Okay, the domain is all real numbers, or negative infinity to positive infinity. And the range shifts a little bit. It's not every integer. It's every third integer. And we don't exist at 0. It's every third integer up 2 units. So we start at 2. Or down 1 unit, however you want to look at that. Okay, so when addressing the range, you have to tell the interval at which the integers are occurring. So in this case, it's every third interval, or integer, sorry, because our a value is 3. So every step occurs at multiples of 3. And then we shifted our starting point up 2 units. So our steps occur at 2 and 5 and 8 and -1 and so forth. Okay, so you could say every third integer starting at 2. Totally fine with that. Or, for notation purposes, you can say every third integer, because that represents integers in multiples of 3, starting at 2, or starting at -1. We know because of the reflection, this is not increasing. Oh gosh, sorry about that, guys. So we're going to say NA. It's decreasing from negative infinity to positive infinity. It is not 1-to-1 because they're all little pieces of horizontal lines. So it most certainly is not passing that test. There isn't a rate of change because they are little pieces of constant functions. There isn't an axis of symmetry. We don't have a minimum or maximum value, and we don't have horizontal or vertical asymptotes. Wah, wah, wah. There is a step function, and I'll move this a little bit so you can see the steps if you need it. Get it? Steps for a step function. Hey, Patterson's jokes are only getting worse, and we're only in September. But that's for part 2, and I want to go into part 3 because it is super fast, and you guys have already discussed it, and my Surface Pro is not letting me do what I need it to. There we go. But it's finding domain and range. Okay, so we're going to go to each graph that was covered in Skill 6 and write the domain and range next to the graph. And then we're going to come back and graph example number 9. Okay, and we'll write the domain and range. So we'll get a bunch of different examples. So let's go back to Skill 6. Let's go back to these guys. I'm going to need to erase some stuff so that we can absolutely write the domain and range. Okay, here we go. So for the first one, we can say that the domain is all real numbers, negative infinity to positive infinity. And we can say that the range is all integers. I will use the symbol, but please know that you can write out all integers if you would like. Okay, and that was with the vertical reflection. For the horizontal reflection, again, the domain is all real numbers, and the range is all integers. There weren't any vertical stretches or compressions. If we go down to where we did see the vertical stretches and compressions, definitely going to affect our range. So for C, our domain is still all real numbers. Are we noticing a trend here? I sure hope so. But the range is going to be every second integer, and it does occur at 0, so I don't need to set a spot for us to start. And then for the example D, yes, the domain is all real numbers, and the range is every half integer. Are we noticing a pattern with the A values? I sure hope so. And then last but certainly not least is E and F. So the domain for E is all real numbers, and the range is still all integers because we jump 1 unit up to each step. And for F, the domain is all real numbers still, and the range is still all integers. So looking at these 6, it appears that the domain is always going to be all real numbers. And what affects the range? Yep, the A value, a vertical stretch or compression. Where we start is affected by our K value. So that's something to note on your notes if you think you'll forget that. All right, ladies and gents, our very last example, example number 9. First, I need to, factor out that B value. So 3 times the greatest integer of 1/2 times the quantity. If we factor out a number we're dividing, so that leaves us with x plus 2 minus 5. All right, our starting point, our h is -2, our k is -5. So at -2, 1, 2, 3, 4, -5, we have our first closed circle. There isn't a reflection of any kind, so I'm going to extend to the right, okay, and then go up. What that means is there wasn't a horizontal reflection, so I'm not extending to the left. There wasn't a reflection at all, so my steps will increase. Okay, B is 1/2, which means my step length will double 2 units. A, I'm just writing it out real quick, sorry, double step length. There we go. A is 3, which means that the distance between the steps is going to be 3 units. Write all this out, sorry. Okay, so I'm going to go up 1, 2, 3, closed circle, extend out 2 to my open circle. Go up 1, 2, 3, closed circle, extend out to my open circle. And one more, why not? 1, 2, 3, and over 2. The domain is all real numbers, or negative infinity to positive infinity, because again, there isn't an x value. That will not give me a corresponding y value when substituted into this equation. And last but not least, our range. The range occurs every third integer, but it starts at either, you could look at it at -2, or it starts at 1, okay? So we could say every third integer starting at 1, or we can say every third integer starting at 1. And again, the starting point is really just where you see it starting. So you could put -2, you could have put 4, whatever your preference would be. All right, excellent, ladies and gentlemen, you have just finished Skill 6 Part 2 and Skill 7.